Hello everybody, hope you're doing well and thanks for joining us for another video, which today continues our debunking of the Apollo detectives, who are attempting to show the moon landings were faked by analysing Apollo 17 photos. But don't worry if you've not seen the first part of this coverage, it's not directly related to anything in this particular video, though if you do want to check it out, I will leave a link up here as well as down in the description. In that video, they talk about a PDF document which they claim was documenting how the Apollo 17 photographs were being edited, when in reality the document was about mineral analysis gathered from scans of the landing site from the Clementine probe in 1994. This time, they're analysing the actual surface photos that were taken during the Apollo 17 missions, which they claim shows evidence that they were faking it all in a giant 4 million square foot studio.
You know what I see in this image that you're showing right now? You see where it says sculptured hills all the way along there? That looks to me like a fourth wall. And you would have all your cameras pointing down.
Here's arrows. They built the set with this. It's movable. They're designed to slide up and down and back and forth. And then they fill it in with the talus there. And that's the same here. And that's the same here where they fill the talus in on that. And these are movable as well. That set that you're looking at is probably 1,000, 1,200 feet wide by, 3,000, 3,500 feet long. That's what they built at Flagstaff.
They're drawing these conclusions from a few different aspects of the Apollo photos, such as claiming the lunar module's location keeps moving between various photos, the mountains in the background don't match where they're supposed to be, nor are they the correct sizes. Except they seem to keep contradicting themselves when talking about directions.
Well, what's interesting is when you come down to the other pictures, that corner in the background there is the southeast corner what you're looking at.
1 minute, Scott is saying this is southeast, then soon afterwards he says the same region is now southwest.
Yeah, but now look how close they are to those hills.
Yeah, that's the southwest corner.
So before we delve into things, let's first nail down the actual layout of the Apollo 17 landing area because it will be very relevant throughout this video. Apollo 17 landed in the Taurus-Littrow Valley. Here's an aerial view of the region which was recorded by Apollo 17 before they landed. And this is an overhead view of the entire region. We have two main mountains, North Massive and South Massive. Connected to the east side of North Massive is the Sculpted Hills, which run around the northeast edge of the valley and meet up with East Massive. Then there's a large gap in the valley floor between the far end of East Massive across to South Massive. Just in front of the western edge of South Massive is Bear Mountain. Across on the other side of South Massive is another gap in the valley where we then have Family Mountain. But things get a bit confusing with all of this because the detectives reference everything using cardinal directions and they say South Massive is straight south and towards Bear Mountain is southeast. But from where Apollo 17 landed within the valley, Bear Mountain is actually straight south and South Massive is more towards the southwest. So to simplify this, I'll try and keep everything referenced based on landmarks, and I'll use the help of Google Moon, which is a great tool for getting your bearings around the Apollo landing sites. If you want to try it yourself, just download Google Earth onto your computer and along the top is a picture of a planet. Click on that and select Moon. From there, you can search any of the Apollo mission sites. And each site also includes geolocated photos and panoramas of the various stations of each mission, which helps you get your bearings. For example, they have an annotated panorama which is made up of two separate pans located next to the lunar module. So, the lunar module front is facing towards Family Mountain and the rear is towards East Massive. And Apollo 17 did 3 separate EVAs. Each one finished with them returning to the lunar module for a rest period, and we can see the routes they took for each EVA. So EVA 1 went south towards Bear Mountain to visit Steno Crater. EVA 2 took a long drive down the valley to the base at the middle of South Massive, and EVA-3 went in the opposite direction, up the edge of North Massive and then along the sculpted mountains. Though for EVA-1, before they drove to Steno Crater, they first set up various lunar experiments, which is an important landmark that the detectives reference as well, so let's make sure we establish where that is. We can see from photo 20701 on magazine 136 that the experiments were laid out a short distance away on the front side of the lunar module. So, let's get into the detectives' analysis, starting with comparing the experiment setup with views from Tracy's rock at Station 6.
Now, if you look over to the right of the geophone rock, there's two features here. Compare those to the features in the Tracy's rock picture on the left. They're the same size.
Yeah, and then you can show them exactly where the LEM is located from there. It's still miles and miles away.
There's the LEM there.
Yeah, it's about halfway there.
Yes, about halfway. So you'd expect the lunar experiments and the geophone rock to be more or less in the same position.
So they're comparing two photos here side by side. The left photo is 22585, which shows part of the lunar experiment with the geophone rock in the background. And the right photo is 21493, taken from Station 6, showing Tracy's rock. And you can indeed see the lunar module in the background. Now, firstly, they're trying to argue about the respective distances and saying the mountains appear the wrong size between the two photos.
You can see how far it is away from the mountain in the background.
Yeah.
And yet on the right-hand one, you can see how close it is to those.
It is. It's as if they're completely different images, and the mountains have been added later, but at the wrong scale.
Scott claims the lunar module is 12 miles from Tracy's rock.
From Tracy's rock to the LEM is about 12 miles in the document.
In reality, it was 2 miles, or 3.1 kilometers, which we can also measure using Google Moon. And on here, we can position the camera above Station 6 and aim it in the same direction as the photo to show that the mountains appear the same as in the Apollo 17 photographs. And in the photo, we're seeing the edge of Bear Mountain closest to the lunar module. This is about 6 miles or 10 kilometers from Tracy's rock. The next layer we're seeing is the edge of South Massive sticking out. This is just over 9 miles or 15 kilometers from Tracy's rock. And then the final peak we see is actually a completely separate mountain located about 25 miles or 40 kilometers away. So from Tracy's rock, the lunar module is about 1/3 of the way to Bear Mountain and less than 1/4 of the way to the edge of South Massive. Now, they've also circled the geophone rock in the close-up photo 22585, and then they've circled this area of photo 21493, which would suggest they're claiming that the circled area is the geophone rock seen from Station 6. But Scott then says that the geophone rock would be too small to see.
You got the geophone rock, it should be in this picture, it's not. And yet these images here correspond to these images.
Well, that rock would be too tiny to see.
Both instances are actually wrong here. That is not the geophone rock, but the geophone rock was visible from Station 6. The geophone rock is actually here. And the experiments are about here. But unfortunately, given that this is a shot with a wide-angle lens that's actually focusing on objects closer to the camera, there isn't really the resolution to see them. Thankfully though, on the later missions from Apollo 15 onwards, they also had a 500mm telephoto lens that was used on the surface, which even the detectives confirm.
Yeah, but that's what the astronaut was using in Apollo 17 that I keep showing in the videos. That is a 500mm telephoto lens that he's using.
Yeah, it is. Yeah.
The lens was mainly for being able to get detailed views of more distant rock formations, such as high up in the mountains that weren't really accessible by the astronauts on foot. But at times they also used this to photograph the lunar module if they spotted it in the distance. For example, I've shown in a previous video that during Apollo 15, they photographed the lunar module from quite a distance. which I was then able to overlay and show it matched the wider shot perfectly, and was even able to use the data to confirm that the distance between the lunar module and the camera was several miles. And we can do it again here, because magazine 139 is all 500mm photos, and shot 21205 is of the lunar module viewed from Tracy's rock. You can see the lunar module, you can see the geophone rock, and you can see the science experiment all laid out. And I can overlay this onto photo 21493, and they're a perfect match. We can also see what the detectives are circling in their comparison is actually a bunch of rocks on the edge of a crater further away. Now, for checking distances, you need a reference of a known size. In this case, the lunar module, which is said to be 7 meters tall. The 500mm lens used on Apollo had a field of view side to side of 6.5 degrees. So, if we work out what portion of the image the lunar module takes up, we can then get an angular size for it. So this copy of the photo is 2,642 pixels edge to edge across the exposed area. It's difficult to tell exactly how many pixels tall the lunar module is, because the photo is not only twisted, but the bottom of the lunar module is also hidden from view. But I estimated it to be about 44 pixels. So 44 pixels is 1/60th of the total height of the photo. Dividing the 6.5 degrees of the entire photo by that 1/60th portion gives an angular size of the lunar module of 0.108 degrees. Putting that into an angular size calculator, we take the angular size of 0.108 degrees and the known height of 7 meters, and that gives a calculated distance of 3.7 kilometers away. Google Moon has it at just over 3.1 kilometers between the lunar module and Tracy's rock, but that is certainly within the margin of error, considering we can't see the bottom of the lunar module to know for sure exactly how tall the lunar module is in the photo, and it's certainly a hell of a lot closer than the 1,200 feet that Scott estimates is the width of the studio, as that would put the lunar module only about 600 to 800 feet away. Amusingly, if you watch the mission back using Apollo in real time, you can see the moment 165 hours 48 minutes into the mission, where Schmidt not only takes the photos, and they talk about taking the photo.
Can you get the lamp from there? Yeah.
But then Cernan takes a photo of Schmidt stood next to Tracy's rock photographing the lunar module, and the whole thing is caught on the TV broadcast camera from the rover. But back to their argument that the mountains in the distances are wrong.
It's as if they're completely different images, and the mountains have been added later, but at the wrong scale.
Oh yeah, the scale is right out to lunch.
Obviously, with perspective, moving from Station 6 to the lunar module would make the mountains in the background appear larger. And it does. Now, because they're taken at different elevations and from different angles, the perspective changes slightly, so we'll compare the mountains individually. First, South Massive. There's some good features here that we can use as a reference. This white patch and this white line. So, let's overlay the line and then compare them. The mountain is noticeably larger in the closer shot. Shifting the photos to align with the rear mountain, it looks slightly bigger, but the difference is nowhere near as extreme as with South Massive. That fits with a mountain that is physically much further away. And what you will notice is more of the further mountain is obscured behind South Massive on the closer photo. This is because they're not only closer, but they're lower in the valley than when they were viewing from Station 6. And then comparing Bear Mountain, Bear has a little double sloped ridge as well as a crater on the left. So if we align the double sloped ridge, we can see the mountain is bigger in the closer photo, evident by the crater moving further left. But what we can also notice is that despite being smaller from Station 6, more of the bottom of Bear Mountain becomes visible due to the increased elevation. Whereas the closer photo, a lot of the bottom is actually cut off by the crest of the landscape. Though before we move on, Scott later brings up a very strange claim about Tracy's rock.
Like I said, I have looked at that for so long, I am convinced when they were finished shooting the set for the last time that they literally just shotcreted the LEM at Flagstaff into the ground there and left it. You see all this coming across here? It almost looks like there's different pieces of equipment going across a bar here. You can see the pipes running around and all kinds of stuff in here. But that gives you the height, having him standing there. You're looking at a rock that's 24 feet high, and that's the height of the LEM right there.
He says the rock appears to be the same size as the lunar module, and he thinks that the rock is as a result of them concreting over the lunar module. Now, even ignoring the fact that just based on the photo that they show here, Tracy's rock is just over double the height of an astronaut, whereas the lunar module is closer to 4 times the height, but they've already established the lunar module's in the background of the photo.
So you've got the LEM in the picture. People will have to believe that that is the LEM. We can prove it eventually because there are images in which it can be enlarged to the point you can identify it as the lunar lander.
So how can it be both in the background of the photo and inside a rock? But anyway, back to them questioning the sizes of the mountains.
The South Massif is about 7,000 meters across at the base and is 2,300 meters tall. So, if you're that close, if you're at the geophone rock and you're up to it as close as these guys are, you are going to be dwarfed by that South Massif.
Now again, it's not only a matter of size, but also distance. Yes, South Massif is 2,300 meters high, and they landed about 7,000 meters away from the nearest part of it. However, if you're considering angular size, you have to look at the distance to the highest point, which according to Google Moon is more than 11.5 kilometers away.
Does that look like a 7,000 foot tall mountain?
No way.
That mountain would dwarf you.
Yeah, it would.
And I've just Googled some pictures here. What does it look like from the bottom of a 7,000 foot hill on the Earth? Well, I'll tell you, here we take a look at Mount Kilimanjaro. The person taking it is approximately 27 to 2,800 meters at the bottom. You take a look at that, compare that to what we're seeing in Apollo. This makes no sense at all.
Unless they've completely got all the heights of mountains on the moon completely wrong. But they keep saying that's what the figures are.
But whilst they're talking about this and bringing up photos of Kilimanjaro as a comparison, they keep showing a photo of North Massif, not South. North Massif is only 1,400 meters high, so South Massif's about 40% taller, though North is 3 kilometers to the base and 7.5 kilometers to the peak, which does actually offset the height difference. So from the lunar module, both mountains would be a similar angular size to each other. But they're then comparing them to Kilimanjaro as a demonstration that the mountain sizes are wrong. Now, Kilimanjaro's 5,700 meters above sea level, more than double the height of South Massif. They show 2 images to put the point across. Now, there's numerous photos of Kilimanjaro with giraffes in the foreground, and they all appear to be taken from the Abaseli National Park, which is 1,130 meters above sea level. So that's a difference of 3,600 meters, which is still basically the height of North Massif stuck on top of South Massif. But Amboseli National Park is 40 kilometers from the peak of Kilimanjaro. Now, they do highlight it was taken from a much further distance, but they're using it as a case that Kilimanjaro in this image looks about the same size as South Massif. But it's clear that the photo of Kilimanjaro was shot with a telephoto lens, not a wide-angle lens like was used in Apollo. The other image they show, well, I managed to find it on a Google search, but the full version of the image has a Grok logo in the corner, which is Twitter's AI system. So it seems this is actually an AI-generated image rather than any accurate representation, and obviously then no details about what focal length or distance is. Fortunately though, I can offer a closer comparison, because a little over 12 months ago I was in Antarctica at Union Glacier, and the camp was located near Mount Rossman, which is 1,450 meters above sea level. Though Union Glacier itself is about 700 meters above sea level, so Mount Rossman's summit is 750 meters above the glacier. That makes it just over half the height of North Massif. And from the small site where we had our cameras set up is about 4.8 kilometers from the summit of Mount Rossman. So, in terms of angular size, Mount Rossman would be 8.8 degrees versus North Massive being 11.5 degrees. That would mean that for the astronauts on Apollo 17 standing near the lunar module, North Massive would appear roughly 1.25 times the size that I saw Mount Rossman. Though again, focal length plays an important part here. Now, all the Apollo photos we're looking at was shot with a 60mm lens on a medium format camera, which gave an angle of view of 47 degrees side to side. Now, unfortunately, I didn't take any photos of Mount Rossman with a comparable angle of view. However, I did have an Insta360 shooting a time-lapse, and in Insta Studio, you can dial in a specific angle of view for your footage. And this is a 47-degree angle of view. And comparing up North Massive to this view of Mount Rossman, it's exactly the size we'd expect it to be. And there is another important comparison we can make between the lunar photos and these views of Antarctica, which is from this footage, it looks like the mountain is only a short distance away from us, when it's actually several kilometers, and it seems like there's nothing between us but a flat ice sheet all the way to the mountain. But if you look at an aerial view, you can see there is actually an entire camp between us and the mountain. But the camp wasn't visible from our location because the ice actually had a small rise to it and then dropped down slightly. So we could only see a short distance of the ice until that crest, and then everything beyond it was obstructed from view until you get to the mountain. And this is relevant because the detectives keep referring to things as being in the corners, as though the objects are right up against the edge of the valley or the studio.
That corner in the background there is the southeast corner, what you're looking at. This picture that you have up here, that's the southwest corner. We just had shots. The LEM is right up against the South Massive, which is what, how many miles long? 12, 14 miles long? So what's it doing in the southwest corner?
There's the crater there. So you know what you're looking at.
Yeah, the LEM has moved about 7 miles at that point.
And Scott states this is the southwest corner, though again earlier he said that this is the southwest corner. In actuality, this is almost the complete opposite direction. This is more east-northeast. As we established earlier, the lunar module landed facing towards the west end of the valley, so behind it is towards the east. Now, this photo is actually from near the end of the mission, and in the distance, behind the lunar module, we see Gene Cernan after he's parked up the lunar rover for it to be able to record that famous footage of the lunar module taking off. But if we drop back into that panorama view taken from beside the lunar module, what Scott refers to as southwest corner is off in front of the lunar module. What he calls southeast is directly left of the lunar module, and behind the lunar module is where the rover would need to be to view the back of the LEM for liftoff. That is over between East Massive and the sculpted hills, and sure enough, the backgrounds match. No, the lunar module is not in the southwest corner. It's in exactly the same spot that it was before. Scott just doesn't know what direction he's looking. And this photo, given that it's viewing near the front of the lunar module, is quite similar to photo 2701 that I showed earlier on with the science experiments and the lunar module in the background. And we can compare the mountains in the background for both photos, and sure enough, they're the same general shape, but when you flick between them, there is a shift in perspective because the photos aren't taken from exactly the same spot. Now, this photo does make it look like the rover's up against the mountains, but actually it's nowhere near them. The terrain is simply on a rise before cresting down, so there's several kilometers of surface between the rover and the mountains that's just obstructed, much like I saw in Antarctica. At this moment when the photograph's being taken and Gene is setting up the lunar rover, the TV camera of the lunar rover is still recording. It's mostly looking towards the lunar module, but at times it's looking around at various different things, including the Earth. But at one point it rotates to point the complete opposite direction, so you can see there is more terrain in the background behind the rover. The camera then carries on panning round and we can see the sculpted hills and North Massive, and then we can see the astronauts hopping their way back to the lunar module way off in the distance. Then they start to try and tackle the topic of lighting by comparing one of Apollo 17's photos to a photo from Apollo 11 of Buzz coming down the ladder.
I still can't get over this astronaut standing in the shade, and this is what it's supposed to look like, and yet Aldrin is in the exact same position, well, pretty close, and yet Aldrin is lit up like a Christmas tree. But that's what you would expect. You would expect it to be that dark down there.
Yeah, you would.
It strikes me as odd that they could spot Buzz's suit is brighter than Schmidt's in this comparison, but they fail to notice that the rest of the moon is also brighter. The instructions for the Apollo cameras was that if you're in shadow or you're shooting heavily into shade, then you use a wider aperture than if you're shooting in a well-lit area. The photo of Buzz was shooting into a predominantly shaded area, and the focus of the photo was on Buzz coming down the ladder. So the camera was set accordingly for exposing in shade. This means Buzz is made clear, but it overexposes the surface in the background. The photo of Schmidt is a general view of a well-lit area, so is exposed accordingly. If I brighten up the photo of Schmidt so that the surface is a similar brightness to that of Aldrin, the suits are a similar exposure. Buzz is possibly still a touch brighter, but then remember Armstrong was standing quite close to him whilst in full sunlight wearing a bright white suit that would be reflecting some extra light towards Buzz. And finally, comparing this photo of Schmidt to other photos, they notice something else strange about the lighting of the mountains.
They've got the same crater there, the little mound there, same the mound here and the crater there, taken at completely different times on the same roll of film. What have we got there? 20448 in the same magazine as 20494. They were talking about 50 pictures apart.
Well, how can that be so different, 50 pictures apart? The lighting.
Well, they'd have to be out there for about 2 days for that shadow to appear, for the sun to move that much.
Holy cow.
There's the mound there on the left. There's the mound there on the right.
So that whole hill is in darkness. Then that's impossible. 46 pictures later, and it's complete darkness there.
Yeah.
Well, that's not possible. I'm sorry.
They're talking about how the lighting has drastically changed on the mountains in the space of a few dozen photos, and that on the moon, that much change would require some 2 days to pass between the shots. Now, Apollo 17, being an extended J-series mission, spent 75 hours on the moon between landing and liftoff. That's more than 3 days. During which time they did 3 separate EVAs that totaled more than 22 hours, with rest periods in between. Not only that, but they carried around a dozen film magazines for use between 2 cameras over those 3 EVAs, because they carried a mixture of colour and black and white film, and the magazines could be swapped over whenever they wanted. And you have websites like Apollo Surface Journal and Apollo in Real Time, which lay out the missions basically second by second, showing when each photo was taken. And they've got magazine 134 being used by Gene Cernan during the first EVA, up until photo 2448, taken at 123 hours 6 minutes into the mission. Then there's 3 blank shots before photo 2452, taken at 168 hours 47 minutes. That's during the third EVA, more than 45.5 hours later. Even with a note stating this magazine was used again by Gene Cernan during EVA 3. So during EVA 1, when the magazine was first used, the sun was at a low angle off to the east, which had the mountains heavily in shadow. Nearly 2 days later, when the magazine is then used again during EVA 3, at this point the sun is much higher and is illuminating more of the valley, just as Scott predicted would need to be.
Well, they'd have to be out there for about 2 days for that shadow to appear, for the sun to move that much.
And once again, we can even use Apollo in real time to verify this during the TV broadcast.
Okay, I need a magazine too, Bob. I don't have any film at all.
Roger, and that'll be Bravo if you change yours here. You could change it at station 10.
I'll change it here. It's just as easy while we're in there.
Okay.
Cernan tells Houston he needs a new film magazine, and Houston tell him to use magazine Bravo, which is magazine 134. So there you have it. No, there is no lunar module jumping around multiple different locations. This is simply a case of the detectives confusing directions and not considering the topography of the lunar surface. The simplest way to verify all of this is using Google Moon, because it shows the layout of the region and the various locations they visited, and you can compare the photos directly to the 3D landscapes to see everything matches how it's supposed to without needing to move any of the equipment around. And all of it points to a region far too large to have been created and faked here on Earth. And with that, I'm going to wrap this video up. As always, feel free to leave your thoughts in the comments down below. If you enjoyed this video and you haven't already done so, then please do consider hitting the like and subscribe buttons, and hopefully we'll see you in the next video.